Okay, how do we draw and label waves? Well, there's two ways we can graph a wave, two ways we can plot a wave. The first one is against time here, and this wave has the y-axis is something called displacement. And displacement tells me how far away from the rest point something is. So here, at this point here, this is 0, so that's at rest point. And things like water waves, what they'll do is a single point, if we imagine one single point in a water wave, it starts up very high and then it drops as time goes on, gets very low, and it goes back high again, and we get this. Okay, so we get this kind of pattern here. Now, in this pattern we have a couple of features. The first thing is the crest and the trough. Okay, so the crest is the high bit, the trough is the lowest point. We also have this value here, and these are the amplitudes. Okay, now they're equal, the amplitudes are equal. We also have as well the amount of time it takes for one entire wave to pass. So that's distance from peak to peak, or one point in the wave to the same point in the next wave. And this is called the time period. So how long does it take for one wave to pass by? Now the other way we can plot these looks very, very similar, but rather than time over here now, it's distance. And we again have displacement here, so let's just do displacement. And what we find is, if we look along a wave, an entire wave's journey, if we take a snapshot of the sea at any point, then we'll find the wave will look like this. Again, very, very similar to our displacement time graph. And again, these values of A are the same, so here's the amplitude. Now, from here to here doesn't measure time anymore. This is now the length of one entire wave, which we call the wavelength. Now wavelength has a strange symbol we use, it looks like a capital T on its side, called lambda. Okay, and that's how we label waves.